we turned our eyes to galaxies billions of light years away, to black holes, and to the birth of the universe. We built the largest telescopes to see the farthest. While searching for secrets in the depths of space, we didn't realize the greatest mystery was hiding right under our feet, our own planet. Silently, without telling anyone, it began to change its rhythm. The Earth is speeding up, faster than it has been in the last 50 years. On June 29th, 2022, our day was 1.59 milliseconds shorter than normal. This tiny number is a harbinger of colossal forces, billions of tons of melting glaciers, the boiling core, 2,900 kilometers deep in the Earth, and shifting atmospheric rivers. All of them are pushing the planet at the same time. But the real irony is this: while trying to understand the universe, we were missing the ground shifting beneath our feet. If you want to be part of this great awakening, hit the like button and subscribe right now. Because everything we thought we knew about our home is changing. We begin. For years, the scientific community believed that Earth was a reliable top, spinning at a constant speed. Of course, it wobbled slightly, but its fundamental rhythm was always the same. So, we set our time by it, but then the machines noticed, in the basement of a laboratory in Colorado, atomic clocks, so precise they wouldn't lose a single second in 300 million years, reported an anomaly. The planet had completed one full rotation too early, by milliseconds. This was a warning siren, and because we now know that Earth isn't just slowing down, it's speeding up, and faster than at any time in the last 50 years, thousands of kilometers beneath your feet. Something is moving. You don't even think about it. But it's there, an ocean of molten iron and nickel, slowly churning in pitch darkness, at temperatures that would instantly vaporize any machine we've ever built. This is Earth's outer core, and scientists have confirmed that it affects our speed of rotation. This concept is known as core-mantle coupling. Think of it like this: two giant gears stacked on top of each other. When one slows down, the other speeds up to compensate. The liquid outer core and the solid mantle layer above it are not perfectly locked together. So, hauled, they can slip between each other. When the fluidity of the core changes, the rotation of the mantle is also affected, because you and I are living on that mantle layer. This is not a theory. This is a relationship proven by studying seismic waves from earthquakes. The data shows that changes in core flows, subtle, coincide with changes in Earth's rotation speed over decades. So, how deep is this? The outer core begins about 2,900 kilometers below the surface. That's a distance deeper than the width of the United States from one coast to the other. The pressure there is so extreme that iron, which is solid on the surface, turns to liquid. And this moving liquid generates something we rely on every day: Earth's magnetic field. But that's not the most interesting part. Researchers believe these fluid changes occur in roughly 60 to 70 year cycles. If this is true, we may be entering a phase that will accelerate the rotation for years to come. This is why, on June 29th, 2022, our planet broke a record by spinning a full 1.59 milliseconds faster than the standard 24 hours. This means a completely invisible force is silently adjusting the day of every living thing on the surface. But this is only one of the hands pushing the planet. Another one comes from a place we all know: ice. Imagine an ice skater, arms outstretched, spinning slowly. Then she suddenly pulls her arms into her body, and all of a sudden, she starts spinning faster. There's no extra push, just mass moving closer to the center. This is physics. Scientists call it the conservation of angular momentum. Now imagine Earth is involuntarily doing the same thing. Because when the ice at the poles melts, huge masses of water locked on land at the very top and bottom of the planet flow into the oceans. This water is redistributed toward the equator. Mass moves away from the poles and toward the middle of the planet. The effect is tiny. But on a scale of trillions of tons, tiny is more than enough. And here, a paradox begins. The glaciers in Greenland and Antarctica are losing ice at rates confirmed by satellite measurements. Greenland alone loses hundreds of billions of tons of ice every year. This ice turns to water. This water mixes into the oceans, and as the planet's middle expands, like the skater throwing her arms back out, the rotation should theoretically slow down. But it's not slowing down. We are speeding up. This tells scientists two things. Either the effect of the ice is not the dominant force right now, or something else is overpowering it with crushing force. Scientists believe both are true at the same time. Right now, the forces that accelerate the rotation are winning. This is why the clocks we built to keep time no longer match the planet. And this situation has pushed timekeeping experts to discuss something never done in history: a negative leap second, meaning to completely erase 1 second from our clocks. Because it's not just the glaciers that are out of balance. Another force pushing the planet is all around you at every moment. You can't feel it. But it's there. The atmosphere. It doesn't feel heavy to you. You walk through it. You breathe it. It seems like nothing. But the atmosphere is a layer of gas roughly 100 kilometers thick, pressing down on every square centimeter of the Earth's surface. Its total weight is about 5 quadrillion tons. It's almost impossible to imagine this number. Even if you stacked every building ever constructed by all civilizations in history on top of each other, the atmosphere would be heavier, and this massive weight moves. It flows in continent-sized pressure systems, in giant rivers of air circling the planet at different altitudes and different speeds. This angular momentum of the atmosphere is a measurable force. This is why, when strong wind patterns like the jet stream circling the northern hemisphere accelerate or change direction, they transfer tiny amounts of force to the solid planet below. The surface pushes back. The rotation adjusts, and scientists have measured this during strong El Niño events. Major shifts in atmospheric circulation can change the length of a day by fractions of a millisecond. Think of it like the wind pushing a boat. A single gust of wind doesn't change much. But constant pressure from one direction over time moves a massive object. The atmosphere itself is also changing. Warming temperatures are altering wind patterns. So, if the atmosphere could already affect Earth's rotation with its old circulation patterns, the new ones will do something different. But all these forces are just the beginning. Because 384,000 kilometers away, there is a force pulling the oceans toward it every day, every hour. And what that force does to our planet's rotation, is something most people never learned in school. Because every time you look at the ocean, when you see the waves rise, the tides creeping up the beach, you are actually watching the Earth slow down, painfully slow. But it's real. It's a verified fact, and it has been happening for 4.5 billion years. The mechanism is simple. The moon's gravity pulls on the Earth, especially the oceans. So, the water bulges slightly on the side facing the moon, and on the exact opposite side, these bulges are the tides. But the Earth spins faster than the moon orbits. So, the tidal bulges are dragged slightly ahead of the moon's gravitational axis. The moon, in turn, pulls back on these bulges, like grabbing a spinning top by its edge. This pull creates a frictional effect. It steals a tiny amount of rotational energy from the Earth, and this energy doesn't disappear. It's transferred to the moon. This pushes the moon into a very slowly higher orbit. This is fully documented. Laser reflectors left on the lunar surface by astronauts allow scientists to measure the moon's distance precisely. The moon is moving away from the Earth by about 3.8 centimeters every year. And as it moves away, the Earth's rotation slows down in response. How much has our planet slowed down because of this over billions of years? When the first single-celled life appeared on Earth, a day was about 16 hours long. The moon was much closer. So, it has been putting on the brakes ever since. This long-term tidal braking is the dominant force behind Earth's slowdown over geological time. But here is the real turning point in the story. On short timescales like decades and centuries, while tidal braking is real, it remains relatively small compared to the other forces currently at play. The atmosphere, the core, the glaciers, these forces are currently overwhelming the moon's braking effect. So, even though the moon is still slowing the planet down in the long run, Earth has recently been speeding up. Multiple forces pulling in opposite directions, and right now, the ones that accelerate are winning. For a long time, scientists assumed Earth's center was simple, a solid ball of iron, dense, hot, locked in place by unimaginable pressure. It stood perfectly still while everything else revolved around it. That assumption was wrong, because in 2023, a study published in the journal Nature Geoscience sent shockwaves through the scientific community. The researchers analyzed earthquake vibrations passing through the planet's interior, seismic wave data, and they compared records spanning decades. What they found was alarming in its simplicity. The inner core had slowed down. It hadn't stopped completely. But this solid iron ball, which had been spinning slightly faster than the rest of the Earth for years, appeared to have slowed. Some data suggested it was now nearly matching the rotation of the outer layers. Some interpretations of the data even implied it had started to spin slightly backwards. This is still being debated, a real-time scientific mystery. Other researchers challenged parts of this interpretation. But the fundamental observation was confirmed. Seismic waves passing through the inner core are arriving differently than they did decades ago. This indicates that the core's orientation or rotation has changed. Nothing can access this solid ball, buried 6,400 kilometers below the surface and roughly the size of the moon. So, why this change began is not really known. Some researchers link it to the 60 to 70 year cycle seen in the core-mantle coupling. Others think it's related to pressure changes from the fluid dynamics of the outer core. But why does this matter? Because the inner core, the outer liquid core, the mantle, and the surface crust do not rotate as a single locked system. They interact with each other through friction, magnetic forces, and gravitational coupling. If the inner core's rotation changes, this effect can ripple upwards. It can affect the rotation speed at the surface, not instantly, but measurably, over years and decades, because all these internal changes are causing something strange on the surface. The Earth does not stand perfectly upright, nor does it spin perfectly steady. It wobbles. This is a verified, shop-measured phenomenon with a name: the Chandler Wobble. It was discovered in 1891 by the American astronomer Seth Carlo Chandler. It describes a small, irregular oscillation in the Earth's axis of rotation, the imaginary line from pole to pole that the planet spins on. This wobble causes the geographic North Pole to trace a rough circle about 9 meters wide over a period of about 14 months. Not kilometers, just 9 meters. And yet, this tiny wobble has been tracked by scientists for more than a century. It's clearly visible in the data. But then, around the year 2000, the Chandler Wobble slowed down significantly. For a period of a few years, it almost stopped. This was so unusual that scientists took a close look. The wobble started up again. But more recently, the direction of the wobble has changed. NASA data confirmed that in 2021, the Earth's axis of rotation and the wobble around it shifted eastward. The speed of this shift accelerated around the year 2000. The suspected causes were ice loss from Greenland and groundwater depletion, the very forces we mentioned earlier. This is important because the axis of rotation is not just a mathematical concept. The actual physical poles are therefore slowly moving across the planet's surface. This is a 9-meter wobble in the axis of a 12,700 wide planet, caused by melting glaciers, boggies pumped groundwater, and movements 6,400 kilometers underground. But the planet is physically reorganizing itself around a moving center. When all these forces come together, the picture that emerges is astonishing. The core, the glaciers, the atmosphere, the moon, and human activity, all pushing and pulling on the planet at the same time. Each layer is talking to the other, transferring momentum back and forth. The Earth's rotation speed is not controlled by a single thing. It is the result of all these systems working at once. We now know these theoretical forces. We understand the flows deep in the core, Nakit, the mass shift of ice at the poles, and the tidal breaking of the moon. But now we wonder, how do scientists measure these effects? What is the real tangible evidence for these invisible forces? Because the real story lies not in the theory, but in the findings from the field. But it's time to find out what the instruments deployed across the planet are telling us, because what they discovered is even more. And what they discovered was even stranger than these models had predicted. The theoretical forces were one thing, but the data was telling another story. Real, concrete, measured findings. And now comes the real shock. Because these findings showed that the planet was not just changing, but behaving at the very limits of known physics. Here are the facts. It all started in the heart of the planet. Scientists thought the center of the Earth was simple, a solid ball of iron, fixed, motionless, locked in place for billions of years. But we were wrong. So very wrong. Because a shocking study published in 2023 changed everything. Researchers analyzed earthquake waves passing through the planet's interior. They compared decades of data, and they found something impossible. Earth's solid inner core had slowed down. This should not have happened. This massive, old, moon-sized ball of iron had been spinning slightly faster than the rest of the planet for years. That was the accepted model. But the new data showed this rotation had come to a grinding halt. Some interpretations even suggested it had started to spin slightly backward. Think about it. 6,400 kilometers beneath your feet. A structure under unimaginable pressure is suddenly changing its rhythm. This discovery sent a shockwave through the scientific community. Because this is not just an academic curiosity. A slowdown in the inner core transfers angular momentum to the outer layers, meaning a change deep inside directly affects the rotation speed at the surface. The record-breaking short day recorded on June 29, 2022, might be a reflection of this internal drama. Scientists asked, was this a cyclical event, or the beginning of something entirely new? They had no answers, only more questions. But this was just the tip of the iceberg, because, on the surface, another impossible event was happening. East Antarctica was a fortress. That's what scientists said for years. Thick, cold, ancient, locked in place by its own mass. West Antarctica is the unstable one, they said. That's the one to watch. But in 2022, satellite data sounded an alarm, a scream. The Conga ice shelf, a floating platform of ice the size of the city of Rome. It was attached to the coast of East Antarctica. And then? It was gone. Completely. In a matter of days. An ice structure that had existed for thousands of years. Disintegrated and dispersed in less than a week. This was the largest ice shelf collapse ever recorded in East Antarctica. This should not have happened. Especially not this soon. Ice shelves are important because they are buttresses that hold back the glaciers behind them. They don't sit on land, they float on the ocean. But they slow down the flow of ice from behind them into the sea. When an ice shelf collapses, the glaciers it was holding back can accelerate toward the sea. The break was gone. This is important for Earth's rotation because mass that was sitting near the axis of rotation, at the bottom of the planet, flows into the ocean and is redistributed outward. This affects the rotation. The collapse of Conga showed scientists this. Even the place they thought was a fortress had weak spots, and the forces triggering those weak spots were moving much faster than they had predicted. But the biggest shock didn't come from the ice or the core. It came from us. No one planned this. It wasn't anyone's intention. But in the last century, the things that humans have built, pumped, and moved on the surface have physically altered the planet's rotation. This is a verified scientific fact, published in peer-reviewed research, and the scale is truly staggering. Let's just start with water. Throughout the 20th century, humans extracted enormous amounts of groundwater from aquifers beneath the continents. Underground reservoirs that had stored water for thousands of years. This water was used for agriculture, cities, and industry, and most of it eventually evaporated or flowed into the ocean. A study published in 2023 calculated that between 1993 and 2010, human-driven groundwater extraction shifted enough mass from underground reservoirs to the ocean. This shift measurably altered the Earth's axis of rotation. This is not a metaphor. This is physics. The planet tilted very slightly because of where we moved the water, the physical pole shifted about 80 centimeters east due to groundwater depletion. This is the same mechanism as melting glaciers, the movement of mass from one place to another. Only this time, humans did it directly by pumping water from underground. This discovery showed scientists a disturbing truth. Human activities had now become a geological force on a planetary scale. We could affect the rotation, even unintentionally. These findings show something is deeply wrong. But how? What is triggering these anomalies? Because the mechanisms behind these discoveries are much more, and these mechanisms were much deeper than what we saw on the surface, far more connected. Because each of these findings was shocking on its own. But together, they proved that the planet is a network of systems talking to each other, fighting with each other, and changing each other. And some of these systems were hidden in places beyond our wildest imaginations. You thought Antarctica was just cold. But it's a continent, a landmass, buried under ice that is nearly 5 kilometers thick in some places. And under all that ice, buried in the depths, is a landscape. It's mountains, valleys, and lakes that most humans have never seen. Scientists are studying this hidden landscape for one reason: because it is changing, and that change will affect the Earth's rotation in ways that won't fully manifest for decades. There are lakes under the West Antarctic ice sheet, not on the surface, under the ice. They are formed by geothermal heat, freshwater lakes sitting in the dark, under kilometers of frozen ice. Scientists have detected more than 400 of them under the Antarctic ice. This should not have happened. Some of these lakes are interconnected. Water flows between them through subglacial rivers. This means rivers existing in total darkness, under crushing pressure. These lakes act like lubricants. When they drain or fill, the ice sheet above them can slide more easily or more slowly over the bedrock. This affects how fast the ice on the surface moves toward the coast. It determines where and how fast ice enters the ocean. This is verified science. Satellite measurements and ice-penetrating radar have mapped many of these lakes. What does this mean? Faster ice movement means faster mass loss to the ocean. It means faster mass redistribution. It means a faster change in how the Earth's weight is balanced. These subglacial lakes are part of the machinery driving how fast that change happens. But something discovered in the oceans showed that this feedback loop was much bigger. The ocean is not a stagnant pool. It's a moving system, a global conveyor belt that transports heat from the tropics to the poles. Scientists call it the thermohaline circulation. And it's one of the most important climate systems on Earth, and Earth's rotation helps to run it. This is verified physics. As the Earth spins, it deflects moving water and air. This is the Coriolis effect. It's why hurricanes spin counterclockwise in the north and clockwise in the south. Here is the finding. The Atlantic thermohaline circulation has slowed significantly in the last century. Studies using sediment records and oceanographic measurements put it at its weakest point in over 1,000 years. This was the signal of a system collapsing. Why is this so important? Because if this conveyor belt weakens significantly or collapses, the redistribution of ocean heat around the planet changes dramatically. Ocean mass shifts, temperatures at the poles change, ice melt patterns change, and each of these changes feeds back into the rotation. Think of that cycle again. Rotation affects ocean currents. Ocean currents affect ice melt. Ice melt affects mass distribution. Mass distribution affects rotation. One system pulling the next in a circle. Scientists are now building models that show the interactions between these systems are stronger than previously thought. This discovery proved that not a single part of the planet is isolated. Everything was connected. And one of the strangest proofs of this connection came from a movement made by the planet itself. These discoveries, not from the slowing of the inner core, to the collapse of glaciers, to humanity shifting the planet's axis, show that something is deeply wrong. Each finding was an alarm in itself. Together, they were proof that the planet was moving out of its known state of equilibrium. So how do the mechanisms behind these discoveries work? How exactly do these forces interact with each other? How can the slowing of the core change the rotation at the surface by 1,000th of a second? How does the collapse of an ice shelf affect the planet's wobble? These are not what happened questions, but how does it work questions. And the answers require digging into deeper physics, more complex models, and the hidden connections between the planet's layers. Behind each of these findings, there is a complex machine as old as the planet itself. And to understand how that machine works, we now need to go much deeper than the surface. Because how each part connects to the other is the most. But how exactly does this complex machine work? What are the physical mechanisms behind the shocking discoveries? Let's now slow our pace a bit and descend beneath the surface, into the heart of the data. Because behind each finding, there is a process as old and complex as the planet itself, and understanding this process allows us to see how everything is connected. It all begins in the heart of the planet, in that invisible engine. The mechanism we call core-mantle coupling is actually like a dance between two massive nested parts. On the outside, you have the outer core, a liquid ocean of molten iron and nickel about 2,250 kilometers thick. On the inside, you have the mantle, the solid rock layer we live on. These two layers are not rigidly attached. Like a ball bearing inside a car wheel, there is some slip between them. What so? When the flow rate of the liquid metal in the outer core changes, it exerts a torque, a twisting force, on the mantle. If the core flow slows down, due to the law of conservation of angular momentum, it slightly speeds up the rotation of the mantle and crust above it. This is an effect that occurs on the scale of decades. So how do we know about this movement thousands of kilometers beneath us? The answer is hidden in earthquakes. Earthquakes emit seismic waves that travel through the planet's interior. These waves act as a kind of planetary ultrasound. P waves, pressure waves, can travel through both solids and liquids, while S waves, shear waves, can only travel through solids. The fact that S waves cannot pass through the outer core is the most definitive proof that it is liquid. But so, by analyzing decades of earthquake data from around the world, scientists map how much these waves slow down or speed up as they pass through the core. Changes in this data show them how the core's fluidity is changing, and how that in turn affects the rotation at the surface. It's like putting a stethoscope to the heart of the planet, instead of watching stars with old telescopes. Because this mechanism is the strongest candidate to explain why we see slight oscillations in the rotation speed in 60 to 70-year cycles. This is Earth's own internal heartbeat, but the planet doesn't just have a heart. It also has a memory, and this memory goes back tens of thousands of years. This mechanism is called post-glacial rebound. To understand it, Think of a memory foam mattress. When you place a heavy ball on it, the mattress depresses. When you remove the ball, the mattress slowly returns to its original shape. During the last ice age, which ended about 11,700 years ago, large parts of North America and Scandinavia were covered by enormous ice sheets, up to 3 kilometers thick. This immense weight crushed the crust beneath it downwards by hundreds of meters. When the ice melted and this load was removed, the crushed crust began to slowly rise back up, just like the memory foam mattress. And this process is still ongoing. This is not a theory. It is a fact confirmed by GPS measurements. For example, some parts of Scandinavia are still rising at a rate of about 2.5 centimeters per year. This uplift is critically important for the Earth's rotation, because redistribution mass that was previously crushed horizontally is now moving vertically upwards. This means the mass is being redistributed relative to the planet's axis of rotation. In physics, this is called a change in the moment of inertia. When mass moves closer to the poles and rises, the planet's rotation slows down slightly. This effect is in the opposite direction to the effect created by the modern ice melt happening now. While modern ice melt tends to slow the planet by moving mass from the poles to the equator, post-glacial rebound creates a different slowing effect by changing the planet's shape. This mechanism is so powerful because it's the result of a massive shift in mass that has been ongoing for tens of thousands of years. For scientists to accurately understand the rapid changes of today, they must subtract this slow and steady background signal from their equations. It's like filtering out the constant hum in a room to be able to hear the whispers. So, how do we measure all these millisecond changes so precisely? By looking at the stars? No. The answer lies much deeper in the sky and in an incredible technology. The name of this mechanism is Very Long Baseline Interferometry, or VLBI for short. Think of it like two people listening to a distant clap of thunder. One will hear the sound a moment before the other. If you know this tiny time difference and the distance between them, you can calculate the direction of the thunder with incredible precision. VLBI does exactly this, but instead of sound, it uses radio waves, and instead of thunder, it uses quasars. Quasars are galactic cores billions of light years away, and are among the brightest objects in the universe. They are so far away that they are considered almost completely fixed reference points in the sky. 2 or more giant radio telescopes on opposite sides of the Earth simultaneously record radio signals from the same quasar. Because the Earth is rotating, one telescope receives the signal with a delay of a fraction of a billionth of a second compared to the other. Computers analyze this time difference to calculate the distance between the telescopes, and thus the Earth's orientation in space and its rotation speed, with a precision of a few microseconds, or a millionth of a second, compared to the old method of measuring the time it takes for stars to return to a specific point, which was used for centuries. This is like comparing an hourglass to an atomic clock. VLBI technology is what tells us, with absolute certainty, that the planet is wobbling, speeding up, and slowing down. This mechanism is so effective because it gives us not a relative measurement, but an absolute measurement based on the fixed points of the universe itself. It's like saying the Earth is a rotating ruler, and the quasars are the fixed marks on that ruler. These mechanisms allow us to listen to the Earth's interior, read the planet's geological memory and measure its rotation with cosmic precision. Each one puts a different piece of the puzzle in place. But this is only part of the story. These methods measure the planet's shape and speed. But what if there was a mechanism that directly weighed the mass itself? The weight of the melting ice or the pumped groundwater? What if there was a system flying around the planet that could precisely measure how much lighter an ice sheet became in a year? Or how much an aquifer was depleted? Then, we could solve the other critical half of the equation. Because such a system exists, and what it has found shows how and where the Earth's weight is changing. And this change is being documented by a mechanism that directly measures the planet's gravitational field. Because such a system exists, its name is GRACE, the Gravity Recovery and Climate Experiment, and its successor, GRACE, Follow On. This mechanism relies on two satellites, flying around the Earth and talking to each other. These two satellites follow each other in the same orbit. At a distance of about 220 kilometers, just like two cars driving very close to each other on a highway. But they are in constant communication with microwave signals that can measure the distance between them to a precision of 1/10 the width of a human hair. This incredible precision gives them the ability to detect even the slightest changes in Earth's gravitational field. Here's how it works. As the lead satellite passes over an area of denser mass, like a giant ice sheet in Greenland, it is pulled a little more by that area's gravity. So, it momentarily moves a tiny bit further away from the satellite behind it. Seconds later, when the trailing satellite reaches the same point, it too accelerates, and the distance between them returns to normal. Computers continuously record these microscopic changes in the distance between the two satellites, and over time, they create a map of mass changes on the Earth's surface from this data. This technology is like weighing from space how much an ice sheet has lightened. Instead of going to the glaciers to directly measure how much ice has melted. GRACE data has confirmed with precise numbers that Greenland has lost billions of tons of ice since 2002, Yachatsin, that underground aquifers in India and California have been depleted, and the seasonal water storage cycles in the Amazon basin. This mechanism is so effective because it directly measures the mass redistribution that affects the Earth's rotation. While VLBI tells us how the planet is responding, GRACE tells us what is pushing the planet. Together, they create a complete cause and effect picture. But the story doesn't end here. See, because there are other, more indirect but equally important mechanisms at work on the planet's surface and in its depths. One of them is the elasticity of the Earth's crust itself. We think of the ocean floor as a rigid Kazichin's unchanging foundation. But it's not. The weight of billions of tons of water on it stretches and bends the rock of the ocean floor. When sea level rises and water is redistributed, this pressure also changes. The solid rock of the ocean floor is being pushed in a slightly different way than it was a century ago. A stretching rock is a shape-changing rock, and a shape-changing planet rotates differently. This mechanism is part of a broader phenomenon known as surface mass loading. It includes not just the oceans, but also water movements on land, the seasonal expansion and contraction of snowpacks in mountains, the slow drying of wetlands, the filling of massive man-made reservoirs. All these water movements redistribute mass, and because these movements happen on or near the surface, They have a proportionally greater effect on rotation compared to the deep internal forces of the planet. Because they are farther from the axis of rotation. This is the leverage effect. It's much easier to push a door from its handle than from its hinge. Scientists have now created detailed models that include all the effects of this surface mass loading. They compare these models with satellite measurements from GRACE and rotation measurements from VLBI. When the models match the data, it confirms that the calculation is correct. But when they don't match, when there is a gap between what the models predict and what the satellites see, it points to a missing source. In recent years, some of these gaps have narrowed as models have improved. But others still persist, and this residual signal is pushing scientists to investigate new and more subtle mechanisms. This is science itself, mapping the unknown. All these techniques prove that our planet is a dynamic system. We listen to the core with seismic waves. We track the crust's rebound with GPS. We time the planet's spin with quasars, and we weigh its changing mass with satellites. Each mechanism tells us a different part of the story. We see the decadal dance of the core-mantle coupling, the millennial memory of the post-glacial rebound, and the instantaneous mass changes from GRACE. Thanks to these tools, we know that the Earth's rotation is no longer a mystery. It is a measurable, complex symphony where all these forces converge. But that's not what's most exciting. What's most exciting is the climax of the story these mechanisms are telling us. All this data is pointing in one direction. The planet is not just changing, it is accelerating. And the consequences of this acceleration are appearing in the most unexpected places, in the most surprising ways. Now, it's time to put these technical details aside and see the real-world drama created when all these forces come together. The climax. Because, in the next part of this story, everything starts to spin out of control, and the greatest discovery may not have come yet. And now comes the real miracle. No, the real drama. Soft because those mechanisms, those precise clocks and satellites, they weren't just telling us the planet was changing. They were telling us a symphony, complex, powerful. But then the drums hit, the rhythm changed suddenly. The symphony became a war march. The real drama was beginning. The whispers from beneath the surface turned into a deafening scream. This is the moment where theories end and facts speak. This is the moment the planet answers us. And its answers, hiked, were far beyond our expectations. Much faster, much more violent. Time to accelerate. Welcome to the climax. June 29th, 2022. Mark the date. That day was the shortest day in the last 50 years. Since humanity began measuring with atomic clocks, a record. For billions of years up, the Earth had been steadily slowing down. Due to the moon's tidal breaking, by each century, a day grew longer by about 1.7 milliseconds. This was the iron law of physics. This was the accepted truth. But not that day. That day, the planet completed its standard 24-hour rotation a full 1.59 milliseconds early. This wasn't just an anomaly, this was a rebellion. It was like a river running uphill against gravity, because it wasn't just that day either. In the year 2020, Earth broke this 50-year record a full 28 times. The planet had hit the gas. This was not supposed to happen. How was this even possible? How could a billion-year-long trend of slowing down suddenly reverse? What force, so sudden and so powerful, had come into play that could overcome the massive braking power of the moon? These questions shook the scientific world. Because this wasn't just an academic curiosity, the institutions that manage global time began to seriously discuss something never done in history: a negative leap second, meaning to completely erase 1 second from all the world's clocks, because our clocks could no longer keep up with the planet's speed, to steal from time itself. This, however, beyond just a data point, was the most concrete most jarring proof that the system was in a state of fundamental change. Scientists were in shock, because the engine behind this acceleration was working much deeper and in a much stranger way than they had ever imagined. And the real earthquake was just beginning. But the real shock was underground and very deep, 6,400 kilometers under your feet. At the very heart of the planet, it was impossible. But the data was there. For years, we thought Earth's solid inner core was a stable, reliable marble, spinning slightly faster than the surface. This was a model proven by seismic waves. But in 2023, a study published in the journal Nature Geoscience shattered that model. Researchers compared decades of earthquake data, the vibrations passing through the planet's interior, and they found something incredible. That giant, moon-sized ball of iron had not just slowed down, it had almost stopped. And some interpretations of the data implied something even more mind-boggling. It might have started to spin slightly backward, the heart of the planet, turning backward. How could this be possible? How could a structure, spinning for billions of years under unimaginable pressure and heat, suddenly change its rhythm? It was like the largest gear inside a clockwork mechanism suddenly starting to stutter. This finding had the effect of a bomb in the geophysics community. Because, due to the law of conservation of angular momentum, it would have an inevitable consequence. If the inner core slows down, that momentum has to go somewhere. It would be transferred to the outer layers, to the surface, to us. A slowdown on the inside would cause an acceleration on the outside. That record-breaking short day in 2022 was perhaps just a reflection of this internal drama. Scientists were at a loss. Was this part of a natural 60 to 70-year cycle? Or was it the beginning of a completely new, unprecedented phase in the planet's history? There were no answers, only bigger, more disturbing questions. Because the planet wasn't just breaking apart from the inside, but also from the outside. East Antarctica. It was untouchable, a fortress. That's what scientists said for years. A cold, ancient, and stable giant, with its ice reaching 5 kilometers in thickness. The real problem is in the west, they said. The fortress is sound. But the fortress fell, right before our eyes, in an instant. March 2022. Satellite images confirmed the impossible. The Conga ice shelf, a floating platform of ice roughly the size of the city of Rome, that had existed for thousands of years. It had completely disintegrated. In a matter of days, it was gone. This was the largest ice shelf collapse ever recorded in East Antarctica. This was a record, child's, and a terrifying omen. This should not have happened. The models had not predicted this, or at least not in this century. Ice shelves are buttresses that hold back the massive glaciers behind them. When they collapse, it's as if floodgates have opened. The glaciers behind them accelerate their flow into the sea. The the brakes had failed. This was disastrous news for the Earth's rotation, because billions of tons of mass that had been sitting near the axis of rotation at the very bottom of the planet would now start to mix into the ocean and redistribute toward the equator. This was a force that would change the planet's balance, but affect its moment of inertia, and slow down the rotation in the long run. But the speed of this collapse shocked scientists. How could such a stable region collapse so suddenly and catastrophically? This showed that the system's sensitivity was far beyond what was predicted. It was a sign that the planet's feedback loops were starting to spiral out of control. Researchers were horrified, because the cause of this collapse wasn't coming from above, from the air. It was coming from below, from the warming ocean, and the one responsible for the warming ocean was clear. And then the mirror turned to us. We were the killer. Yes, it was us. No one planned it. No one intended it. But it was the truth, and this was perhaps the most disturbing of all the discoveries, because this time the fingerprints were ours. A study published in 2023 that rocked the scientific world proved that human activities had physically shifted the Earth's axis of rotation. This is not a metaphor. This is a measured, more-sentient, verified fact. The mechanism was shockingly simple. Between 1993 and 2010, humanity pumped a full 2,150 gigatons of water from underground for agriculture and industry. This is a mass of water that is hard to imagine, and this water was taken from underground reservoirs and moved to the surface, akashiks, and from there to the oceans. The mass was shifted to a different part of the planet. This mass shift upset the planet's balance, and the result? The Earth's geographic North Pole, for this reason alone, shifted about 80 centimeters further east than it should have. We tilted the planet by drawing water from underground. We changed the way the Earth wobbles, like changing the weight on a spinning top. How was this possible? How could we, tiny beings on this massive planet, affect its fundamental physical property, its axis of rotation? This discovery slammed the fact that humanity has become a geological force in our faces. Our activities are no longer local. They are planetary, and their consequences, at the most fundamental level, are even affecting the Earth's posture in space. When scientists first saw this data, they couldn't believe it. But the models were run again and again. The calculations were confirmed. The conclusion was certain. We did it. The shortest day, a core turning backward, a fortress collapsing, and a planet whose axis we shifted. These are not independent events. They are the symptoms of a system that is spiraling out of control. They are all connected. So what does this all mean? Where is this accelerating, wobbling, fragmenting planet being pushed by us, heading? Because there is more to this story. The place where these events converge is leading us toward a threshold. And on the other side of that threshold, there wasn't just more data. There was something more fundamental, a planetary scale identity crisis. Because when all these events combined, they showed that the planet itself had entered a feedback loop. The rotation affects the oceans affect the ice affects the rotation, a cycle. But now this cycle was accelerating, and the most terrifying proof of this acceleration was perhaps the quietest one. It came from the sky, from the satellites, an earthquake, the 9.1 magnitude earthquake that occurred off the coast of Japan in 2011. One of the most powerful in history. It didn't just shake the land, it shook the planet, literally. The earthquake suddenly displaced a massive amount of mass on the ocean floor. This sudden mass shift changed the Earth's moment of inertia, and the result? It was confirmed by satellites. That day, that single event permanently shortened the length of Earth's day by 1.8 microseconds. 1.8 millionths of a second. It seems insignificant. But it's not. Because it proved that a single event, a tremor lasting a few minutes, could permanently change a fundamental property of the planet, its rotation speed. How was this possible? How could a single earthquake instantly rewrite billions of years of geological balance? It showed just how delicate a balance the planet stands on. Like a tightrope walker, it could lose its balance with the slightest shake, and that earthquake was just the beginning. Because the Pacific Ring of Fire has been extraordinarily active in the last 2 decades, the great earthquakes in Chile, Sumatra, and Alaska each left their own small, measurable marks on the planet's rotation. Each one shortened the day by another microsecond. For scientists, this was a paradigm shift. The processes they had thought of as slow and steady on a geological timescale could actually occur in sudden, violent bursts, and each of these bursts was resetting the planet's clock. The scientific world began to see the Earth not as a slowly flowing river, but as a pressure vessel that could suddenly explode. It meant understanding that the stress building up under the Earth's crust was not just a local disaster, but also a planetary timekeeper. And the greatest stress was accumulating in the coldest place. And then came news from the ocean itself. Not a whisper, a roar. The Atlantic Meridional Overturning Circulation. Scientists call it AMOC, a massive ocean current system that regulates the planet's climate. A conveyor belt. It transports heat from the tropics to the north. It's the engine that keeps Europe from freezing. That brings rain to the Amazon. And that engine was sputtering. Badly. Data from sediment records and oceanographic measurements confirmed it was at its weakest point in over 1,000 years. This was the worst-case scenario. This was a tipping point. This was a threshold. If this conveyor belt were to stop completely, which some models say is a possibility within this century, the consequences would be catastrophic. Northern Europe could enter a mini ice age. The monsoon rains that billions of people depend on could stop. It meant global chaos. How was this possible? How could the heart of the planet's life support system weaken so much? The answer, Asad, was again in that feedback loop. Fresh water from melting Greenland ice was preventing the salty, dense water that drives the current from sinking. Warming oceans were reducing the temperature differences that fuel the current. And yes, even the Earth's changing rotation. By slightly altering the Coriolis effect that guides these currents, could have been contributing to this slowdown. The scientific community was divided by this finding. Some argued it was natural variability, but the majority agreed that it was one of the most dangerous consequences of human-caused climate change. This wasn't just an ocean current slowing down. This was the planet's circulatory system having a heart attack, and the effects of that heart attack would spread throughout the entire body, the entire planet. This was the greatest fear, and that fear was becoming real. We were exiled from the deepest rooms of our own home. This is a deep cosmic loneliness we experience on our own planet. We are like a child listening to sounds behind a closed door, but who can never open that door. This is one of the most fundamental limitations of being human, to live right on top of the unreachable. But here comes that magnificent but. Even though we can't open that door, we can hear what's behind it. We can understand it. Perhaps this is the greatest miracle. Our bodies cannot descend into those depths, but our minds can. The seismometers we build become the stethoscopes of the planet's heart. The satellites we send into orbit become precision scales that weigh the slightest changes in the planet's mass. Radio telescopes on opposite sides of the world listen to the whispers of quasars billions of light years away and detect a microsecond wobble in our planet's rotation. We, the physically weakest, become the most powerful through our ability to understand. This is not a victory of muscle, but of consciousness. You are living in the middle of this very paradox. You, while your feet stand firmly on a 12,700-kilometer sphere, are looking at a map on your phone based on data collected by those satellites. You find your way every day with the knowledge of this massive, unreachable system. And this knowledge elevates you from being a mere passenger to being a witness. And this witnessing reveals another profound paradox, the paradox of time. On one hand, there is the overwhelming 4.5 billion year history of the planet. There was a world where a day was 16 hours long, where the moon appeared enormous in the sky. There were cycles lasting tens of thousands of years, where continent-sized glaciers crushed the Earth and then retreated. Even now, the land of Scandinavia, rising from under the ice that melted 11,000 years ago, is still rising by a few centimeters a year. This is a timescale beyond human comprehension. Our average 80-year lifespan is less than a second on this geological calendar, an instantaneous flash, just a moment. But on the other hand, there is this very moment, our moment. There is a tragic aspect to this situation too. We will see neither the beginning nor the end of this massive story. We are like foam that appears for a moment on a wave in the middle of the ocean and then disappears. We will not be here to watch the rebound of the land under the ice currently melting in Greenland and Antarctica, which will be completed thousands of years from now. We will never know the state of our planet billions of years from now, when it will be fully locked with the moon, with one face turned towards it. For us, everything is just a tiny piece of the big picture. This is one of the most fundamental sorrows of existence, transience, to appear on stage for just one act of this cosmic play and then disappear. But here comes that but again. What if this act, let's see, the one we are on stage for, is the most important act of the play? Because in this very brief moment, in this instantaneous flash, for the first time in the planet's 4.5 billion year history, a species has built the tools to measure the planet's pulse with millisecond precision. That is us. For billions of years, the Earth spun, accelerated, and slowed down, but there was no one to listen. Now there is. This makes our moment incredibly important. We are the witnesses of change. We are the generation living in the unique moment when the shortest day in history was recorded. When the inner core's slowing was discovered. When an ice shelf collapsed before our very eyes. This is not a curse, but a privilege. This is the chance to exist in one of the moments when the universe becomes self-aware. You are right in the middle of this moment, the days you are living, belong to this exceptional period where records are broken and paradigms are shattered. The atmosphere you breathe is a product of a billion-year evolution and the dramatic change happening right now. You, in this fleeting moment, are witnessing eternity. This brings us to a final paradox, the paradox of power and interaction. On one hand, there is the overwhelming and irresistible force of nature, the energy of an earthquake that destroys cities in seconds, the wind of a hurricane that sweeps everything away, the immense power of ocean currents that determine the climate of continents. As individuals, we are helpless against these forces. We are nothing. But, on the other hand, there is our collective impact, the total action of billions of people who are individually weak. The most tragic part of this situation is that we discovered this power unintentionally, unknowingly, as a side effect. No one woke up in the morning and said, "Today I'm going to shift the planet's axis a little more." We just pumped water to irrigate our fields. We produced energy to light our cities. We built vehicles to travel faster. And all these small, individual actions combined to become a geological force that changed the planet itself, affected its rotation, and disrupted its climate. This is the tragedy of a child who has incredible power in his hands but does not know how to use it. Our power came before our wisdom, and this is perhaps the greatest danger in human history. To have power on a planetary scale without having a sense of responsibility on a planetary scale. But here, there is that hopeful but again, because becoming aware of this unintentional power also creates a choice. If our actions can unintentionally change the planet, then we can also choose to protect it with our conscious actions. This is the transition from helplessness to agency. This is stepping out of the victim role and into the potential of becoming one of the authors of the story. Awareness is the first step of change, and we are now aware. Science holds up a mirror that shows us not only what we have done, but also what we can do. This is hope itself, the potential to understand our own impact and use it for a better future. You are also a part of this collective power. Your choices may seem like a drop in the ocean. But bolts, when billions of drops come together, they can even change the tides. You are not just a part of this system. You are an agent with the potential to change it. We are tiny beings on a massive planet, but we can listen to its heart. We are an instantaneous flash in the ocean of time, but we are witnessing the most critical moment in history. We are helpless against the forces of nature, but collectively we have the power to change the planet. These paradoxes, Lao Tzu, are our story. But there is one more layer to this story, the most personal one, that mysterious and deep connection between the rhythm of this planet and our own inner rhythm, because the breathing of this planet perhaps affects our own breath as well. Therefore, our confidence in our own life story stems not from it being an absolute and unshakable truth, but from it being a unique interpretation that is entirely our own. As we discussed, the fragility of our memories and the limitations of our perception do not invalidate our narrative. On the contrary, they turn it into a uniquely human work of art. Confidence here is not born from the effort to prove the accuracy of every detail. Confidence is born from accepting the fact that we are the creator, the carrier, and the sole owner of that story. Because that story, with all its flaws and gaps, is our existential fingerprint. Just as not every brushstroke on a painter's canvas is deliberate. Not every memory in our life narrative is perfectly recorded, but the resulting picture undoubtedly belongs to the artist themselves. This acceptance prepares us to face the other deep paradoxes of existence. The first, and perhaps the most modern, is the strange dance between connection and loneliness. Never in human history have we been so connected to each other. As digital networks link the most remote corners of the planet, we can see the face of a loved one across oceans in an instant, and witness an event anywhere in the world immediately. This is literally a communication revolution. However, at the very heart of this age of limitless connection, an unprecedented epidemic of loneliness is flourishing. Millions of people, amidst lists of hundreds of friends and a constant stream of notifications, feel profoundly alone. How can we feel so unheard while talking so much, so unseen while being so visible? The tragic truth of this situation is that digital connection often offers an illusion of presence. The bonds formed through screens at Cult often lack depth because they exclude the physical presence, the shared silence, and the unfiltered moments that form the basis of true human contact. Social media profiles become carefully curated trailers of our lives, which traps us in a comparison of our own complex reality with the seemingly perfect lives of others. This state of constant performance alienates us from our authentic selves, creating an isolation within the crowd. This is one of the most sorrowful ironies of modern existence, because our search for connection has unintentionally led us to tools that make us even lonelier. But the very feeling of loneliness created by this digital age is actually the strongest proof of how deeply the human soul desires connection. The fact that the superficial does not satisfy us shows how deeply rooted the longing for something more real, more meaningful, is within us. These technological tools are neither good nor bad in essence. They are merely extensions, and when used correctly, they can be an invaluable bridge for maintaining real friendships and family ties, making geographical distances meaningless. A grandmother seeing her grandchild across the oceans for the first time, or a heartfelt message from an old friend after years. These are the moments when technology can nourish the soul. Hope lies not in rejecting these tools, but in learning to use them more consciously and from the heart. You are living right in the middle of this dilemma. You have probably experienced moments of feeling misunderstood, while having a friend list of hundreds that you have spent hours looking at a screen, only to feel even emptier at the end. But you have also witnessed how a single photo or message from a loved one miles away has brightened your day, warmed your heart. This experience is the contradiction of your era. What is important is not to drown in this digital ocean, but to develop the wisdom to distinguish which drops truly nourish your soul. Because true connection is hidden not in quantity, but in quality, and this search is one of your most fundamental human journeys. The second great contrast is between knowledge and mystery. At our fingertips, we have an ocean of information so vast it dwarfs all the libraries of history. We can learn everything from the beginning of the universe to the intricacies of quantum mechanics, from the languages of ancient civilizations to the map of the human genome. Access to knowledge has been democratized, and curiosity no longer has to go unanswered. However, despite this huge body of knowledge, the fundamental mysteries of existence remain as fresh and unsolved as they were for the first humans. Questions like what consciousness is, what the ultimate purpose of life is, what came before the universe, look even more imposing when viewed from the peak of our mountain of knowledge. How is it that knowing so much can so sharply reveal how little we actually know? The tragic dimension of this situation is the overwhelming feeling created by the infinity of knowledge. And no matter how deep we go into any subject, we realize there are always more layers to discover, more questions to answer. For some, this can lead to an intellectual fatigue or nihilism. If I can never reach the end of everything, what's the point of trying to know? The information bombardment can also dull our ability to think deeply by distracting us and condemning us to a superficial understanding. Knowing a little about everything but understanding nothing fully is one of the greatest traps of the modern mind. This sad truth shows that knowledge is not enough to make us wise, but the veil of mystery that appears at the limits of this knowledge is not an end, but a magnificent beginning. What keeps us humble and constantly fuels our curiosity is precisely this unknowability. If everything were known, if there was nothing new to discover, what a boring place the universe would be. Science, art, and philosophy are bold fishing lines cast into this ocean of mystery. Even if we don't find the answers, the act of asking questions itself makes us grow, expands our minds, and reminds us of how miraculous existence is. Hope lies not in the goal of knowing everything, but in the desire to know itself, in the beauty of that unending journey. Because the universe's greatest gift is not answers, but the questions it makes us ask. You are also a part of this paradox. I am sure you too have set out to learn something about a topic, only to find yourself with many more questions hours later. So perhaps after watching a documentary or reading a book, you realized how complex the things you thought you knew actually were. This is not a failure, but proof that your mind is alive and working. Your personal ignorance is an honest stance in the face of the universe's infinite wisdom. As long as you keep your curiosity alive, your journey of learning will never end. And every new question you find on this journey will be far more valuable than any answer you find. Because these questions are the deepest dialogue you have with the universe. Finally, the third contrast, perhaps the most personal, is between control and surrender. We are driven by the impulse to plan, secure, and control our lives. We make career plans, we save money for retirement, we take precautions to protect our health. Our search for order and predictability is our strategy for survival in a chaotic world. However, when we look back, we see that the most transformative, most meaningful moments of our lives often arose when our plans completely collapsed, when we lost control, and when we were forced to surrender to the flow. We find our greatest strength in the moments we feel weakest. How is it that when we lose our grip on life, we can gain life itself more deeply? The tragic side of this truth is how tightly we cling to the illusion of control when we deny the inherent uncertainty and chaos of life. We experience great pain and disappointment, an unexpected illness, a loss, or a failure can instantly demolish the order we have carefully built. The helplessness we feel in these moments is a reflection of the futility of our attempts to control. Resisting change is like rowing against the current. It only exhausts our energy and pushes us further back. The fear of losing control closes us off to new possibilities and limits our potential. This is a sad truth, because the thing we fear most often opens the door to the thing we need most. But it is precisely in these moments of surrender that a wisdom and flexibility we did not previously possess emerges. When we let go of control, we begin to see the unexpected paths and opportunities that life offers us. Just as a tree can break in a storm, but a flexible reed can bend and rise again. Surrender gives us resilience instead of fragility. This is not a passive acceptance, but rather the art of actively dancing with the flow. True freedom lies not in managing everything, but in learning to be at peace with the things we cannot manage. Hope is hidden not in our plans, but in our ability to stand up and start again, even when our plans are shattered. You have surely experienced this at some point in your life. Maybe you were fired from a job you never wanted, but this situation led you to your dream career. Maybe you were devastated by the end of a relationship, but this separation gave you the opportunity to know yourself more deeply. At a moment when your plans fell through, when you thought everything was over, an unexpected door opened. This is the dance of control and surrender in your life. When life takes control from you, it usually gives you a lesson, a wisdom, or a new beginning in return. If you can choose to be curious instead of fearful in these moments, you will see that life's greatest teacher is uncertainty itself. As you stand amidst all this fragility, uncertainty, and coincidence, which feeling is predominant within you? Is it that subtle ache for the future, that anxious worry for things you cannot control? Or is it that ineffable, relieving sense of gratitude for still being here, for breathing, despite all this chaos, this immense mystery, and your own limitations? Perhaps you feel like a small raft adrift on an ocean, scared, but also in awe of this view under the stars. Perhaps while a storm rages within you, there is also a calm confidence that everything will somehow work out. These two feelings, anxiety and surrender, may seem opposite, but they are actually two sides of the same coin, and most likely, you are feeling both at the same time right now. This is perfectly normal, because to be human is to be a pendulum swinging between exactly these two. As we approach the end of this philosophical stop on our journey, we now know some fundamental truths. We've seen that our memory is an artist, not a recording device, that our search for connection can both unite and isolate us, that our hunger for knowledge leads us to greater mysteries, and that we learn life's greatest lessons when we surrender our attempts to control it. These thoughts, rather than reaching a conclusion, were lenses that allowed us to see the complex fabric of existence more clearly. They showed us that life is not filled with simple answers, but with deep contradictions that must be embraced. We now stand in the light of these truths. This journey did not offer us definitive maps. On the contrary, it taught us that the map is constantly being redrawn, and that the real adventure is the process of drawing itself. This wisdom is a little sad, but also incredibly liberating, because we can now cast off the burden of being perfect, of knowing everything, or of controlling everything. We can now simply focus on being as authentic and wise as we can within all this chaos. Now, armed with all this awareness, we prepare for the final step ahead. On this journey, we have explored the limits of existence and knowledge together. But I haven't told you that our most fundamental assumption, the one-way flow of time, might actually be breakable. Einstein's theories contain theoretical paths to the past, where time is bent around massive objects like black holes. In our next adventure, we will investigate the seemingly impossible physics of time travel. Are you ready to open a window to the past